Right triangle trigonometry. It has been a little while since I asked you out there to bring your A game, your A plus game if you have it. The quadratic formula was certainly one of those assignments. This may be the other one in our integrated 3 year that just takes your full mental, physical, emotional strength. So if you are not in that place right now, I ask you to pause, stretch, maybe eat something, go to the bathroom, whatever you need to do, and then come back ready to just blow it away, to have your A game on display. Because that's what I'm asking today. All right? If you're still playing this video, I hope that means you have squinted your eyes and furrowed your brow and are ready to dive in to right triangle trigonometry. Okay, I have decided as I record this lesson to go to a site for our friends at Lumen, where you can see on the same exact web page, they started with the Pythagorean theorem that we've gone over on this unit. And then on the same page that it explains what a right triangle is, it talks about our hypotenuse, a squared plus b squared is c squared, does a little proof, some examples. Then, boom, it starts talking about trigonometric functions and getting into trigonometry. All right, this is where I want to focus on right now. Ignore the words you don't know. I will explain them. For now, look at your right triangle. We know what this is. It has a right angle. We've been dealing with these with Pythagorean theorem. As I said before with Pythagorean theorem, it is used for when you have two sides of a triangle. That's always a right triangle. And you're looking to solve for the other side. Well, that logically dictates the next question, which is, what do you do if you only have, say, one side of a right triangle and one angle other than your 90? Can you solve for another side then? And the answer is yes, but we have to use trigonometry. We have to use these trigonometric functions. So first, some more vocabulary on our triangle. You will notice that the longest side, our c and our a squared plus b squared equals c squared equation of the Pythagorean theorem, it was called the hypotenuse before. It's going to be called the hypotenuse today. It's going to be called the hypotenuse in the future. It's always the hypotenuse. Okay? Here are the new terms. Now notice this angle t. So this angle in theory can be up here or it can be down here. For the sake of our assignment today and this explanation, it's going to be down here the whole time. If we examine this angle t and then we look immediately to the side that it is pointing to. Notice it's got like a, you think of this as an eye, and it's staring straight ahead into this side. The side opposite from where our angle that we're given and focusing on is staring at becomes our opposite side. Okay, that makes sense. We have this eye, it's staring at the side opposite from it. So we have our hypotenuse, we have our opposite, and then at the end, there are ways that some teachers give to memorizing this. Oh, it's the one next to the eye. It's the one beneath the eye. I just say label it last. Start by labeling your hypotenuse, then go with your opposite, and then after that, just write adjacent on the side left over. It will help you from getting confused and making potential mistakes with it. Once you have your three sides labeled on your triangle, then you come down here to our trigonometric ratios or trigonometric functions of sine, cosine, and tangent. These are all buttons that you have on a calculator, and I'll show you in Desmos in a minute. But for now, here is what they mean. They mean sine is opposite divided by hypotenuse. So literally, whatever this side is over here, divided by this side. Well, what about cosine? That's adjacent divided by hypotenuse. And finally, tangent is opposite divided by adjacent. Maybe take a pause on your video right now, drink a sip of water, take a deep breath. It's a lot of information at the same time, especially if you've never seen this before. But don't worry, we're going to start getting into this. We're going to do a few problems. You're going to get into your groove. How in the world are you supposed to memorize this? This sine, cosine, tangent? Well, I grew up in New Mexico, and that was a place filled with much culture and history. And it included this method that people across the whole nation have tried to learn. And it's this name SOHCAHTOA. SOHCAHTOA. And look how exactly how I wrote this with a capital S, a capital C, and a capital T. And it stands for exactly like you can see below. Sine is opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So SOHCAHTOA, we'll use that throughout our problems today. We're going to use this to solve for x for a side in our right triangle given one other side and one other angle. And I'm just going to show you via an example because this is one of those things that's easiest to learn as you see it, as you do it. So let's just jump right in, open up our assignment, right triangle trigonometry. And I'm going to clear my last distance formula on Desmos, as well as bring this out a little bit and prepare for today by hitting, I need to go a little bit more, don't I? Yes, I need to go out into where I see my functions button down here. Let's get just familiar with the buttons here. And here we got them. Sine, cosine, tangent, as well as a whole bunch of other ones that if you take a full year of trigonometry, you get into things like secant, cotangent, inverse of all of this. For now, don't worry about that. Okay. I'm going to log in just like you guys log in. And let's go. All right. Each of these problems, let's go back to number 1, start to be on number 3. Each of these problems, and notice there are only like 6 of them, right? 6? Yes, 6 of them. Each of these are going to have the same general format. They are going to give you a triangle. We are going to use this one on the screen to draw it. It's up to you whether you draw it on your own paper or just look up here, where angle A is always going to be our 90-degree angle. Angle B is going to be the angle that they give us. They're always going to give us angle B in these problems, and this one it's going to be 49. And that leaves the top to be C. We are then going to follow the directions in the problem and solve for the side that they want us to solve for. All right, so we already know that this is going to be 49 degrees. And this one also says that side AB, that's what this means. Side length AB is 19. So from A to B, I know this is 19. And then it says that we are solving for BC equals blank. So between B and C, that's where I'm going to put my X. Okay. Now, fortunately for me, I have labeled it appropriately in the exact spots to use this right triangle, where I know that my hypotenuse is up here, my opposite side across from 49 is over here, and my adjacent is here. So then we ask ourselves, which side is X on? That's hypotenuse for this one. And then what side is the one that they give us? In this case, AB is adjacent. All right, so we are using our adjacent and our hypotenuse. So now we need to go down here and decide which one is adjacent and hypotenuse. Sine is opposite and hypotenuse. Nope. Cosine is adjacent and hypotenuse. Cool, that's the one we want, cosine. All right, so watch what we do here. So I write the cosine, and inside these parentheses always goes our angle B. So I've got cosine of 49 is equal to, and I need to write out adjacent over hypotenuse. Well, my adjacent's 19, and my hypotenuse is X. So 19 over X. Now, at this point, we have to algebraically solve for X. I can multiply by X and then divide by cosine of 49. But here's my shortcut. If X is on bottom, if it's being divided by like it is right now, that tells us we need to divide. If X is on top, then instead we need to multiply. And I say that, and you're like, well, multiply by what? Well, I'm about to show you. We're going to use our Desmos calculator now, and we are going to always type it in this order. The side length they give us, then either multiply it or divide, in this case divide, our ratio, in this case cosine, and then our angle. Again, this is a lot of information. Pause, breathe, drink some water, because we're going to go into the computation in 3, 2, 1, go. All right, so 19, then we have divided by. And remember to use your numbers here. So if you've been so confused up to this point and just letting it play, write whatever your number is here. So I have my AB divided by, and then we're going to write cosine, which is right here. See it? Okay, cosine. And then angle B. Angle B is right here, 49. See, I guess closing parentheses doesn't matter. It's the same answer either way. We need to round to the nearest hundredth. We've been doing a lot of rounding to the nearest tenth. Let's review rounding to the nearest hundredth now. The tenth, we know from our many lessons, is just one spot. The hundredth is our second spot. So just like we did for the tenth, we could ignore everything that's past the number to the right of the wall. And then we ask ourselves the same exact question. Say, self, is this number 5 or above, like an 8? If so, we give this a shove. So is it 20 or 21? Because 8 is 5 or above, we give 20 a shove up to 21. So my answer is 63.21. Okay. 63.21. And you out there, again, are following the instructions, hopefully perfectly, to do your side length AB divided by cosine 49. Ah! Oh my gosh. All right, so I just paused this video and did some extensive research because this is a brand new thing for me, doing these videos from home. I did not know. So what we did everything right. Here's the problem. Desmos by default uses what's called radians, which is a different unit than the degrees that we need for this assignment. Well, after some research, I figured out what to do. So everybody immediately, hopefully don't hit check yet. If you did, I'm sorry, you're going to make the same mistake I did. Look up here on this little wrench in the top right corner of the screen. I'm not going to lie, I've literally never hit this button before in all the years I've been teaching on this site, but now I need to. When you hit this button up here, you're going to see some very interesting options here. But one of which is down here. It says radians and degrees. And you'll notice that radians is selected in green. Swap it and click on degrees. When you do, look at my answer. 28.96. It's the one we want. Okay, so please, 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 hopefully, I'm going to just keep reminding you throughout every one of these problems if you're watching this. Set it to degrees. The good news is we know that this is going to be the same exact type of problem. So we've already done all the hard work. Now I could just replace my numbers. So everyone's number 1 is going to be our side length divided by the cosine of angle B. In this case, B is now 6 degrees. So 25.14. Wow. How interesting that in live, real time, you saw me figure that out. And hopefully now I helped you all figure it out. So again, going into number 2, now that we've got number 1 right, make sure you have it in degrees. Once you click this button, I hope it should stay here throughout the whole assignment. But it's got to be in degrees or it's going to be wrong. I'm going to close out of this one so it doesn't confuse me. Now, let's look at number 2 and label our problem appropriately. Okay. A, B, C. As I said, for each of these problems, they're going to give us angle B. This case, angle B is 64. 64. They give us now AB. So that's the same one they gave us before. But notice, instead of asking for BC now, they ask us for AC. So AC is over here. So we have our opposite and our adjacent that we're using this time. Let's go down to our trig functions. Opposite and adjacent is tan. So let's write out exactly how we did before. The tan of, remember our angle B always goes on the inside, so 64 is equal to, and we follow the directions for tan, opposite over adjacent. So x over 18. Remember my shortcut. If x is on top, We multiply. If x is on bottom, we divide. Before it was on bottom, that's why we divided, but now it's on top, so we multiply. So I'm going to type in 18 times the tan of 64. 18 times the tan of 64. I'm closing this in 3, 2, 1, 0. Making sure that my calculator is in degrees. I'm going to say that a lot since that's a big mistake here. I need to type in 18 times, and I'll see if this works without the times after this, the tan of 64. Is that the same thing if we eliminate the times? Yep. Okay, so you don't even need the times. 18 tan of 64. The times is implied. 36.90. Do we leave it 90 or round up to 91? I look at the third digit here. It's a 5. That's 5 or above, so I give it a shove. 36.91. Just blown away that I'm learning so much today as well. Having to have my own A-plus game with research to figure out degrees versus radians in Desmos. All right, 2 down, 4 to go. Hopefully you're seeing the pattern now. Let's go back to our triangle. Let's label it again. A, B, C. In this case, B is 27 degrees. They give us AC. Okay, so that's the opposite side. They tell us is 5. Opposite and what? BC is hypotenuse. Well, it makes sense. We've used cosine and tan. It is only fitting now that we use the opposite and hypotenuse one of sine. So let's write it out. Sine of our angle B is opposite over hypotenuse. Ooh, x is on bottom now. That means it's being divided by, so we're going to divide. 5 divided by the sine of 27, closing in 3, 2, 1, go. All right, so this was number 2. Let's get rid of that for confusion. So whatever your AC length is, divided by the sine functions, there it is, of our angle B. 11.01. The 3 makes it not round up. 11.01. And if this is super confusing to you still, just wait until I get to this computation part, maybe with the diagram there, and just copy from there. I deeply look forward to being back with you in person and helping you when you're confused, because this is really complicated. Again, A-plus game today. I said that for a reason. So if you're confused out there, just keep trying, but know that you're just doing the best you can do, and that's all I can ever ask for my students here. All right, let's go again. A, B, C. B is 25 degrees. Notice on this one they give you AC, so that's the opposite again. And they're asking for a B. So opposite and adjacent, we know now that we've done all 3 of them. That's tan, SOHCAHTOA. So the tan of 25 is opposite over adjacent. X is in the bottom again, so it is being divided by. So we're going to do 13 divided by the tan of 25. 3, 2, 1, close. This is the part again if you're zoning out. Type your AC divided by the tan of your angle B. 27.878. The 8 is 5 or above, so we round it up to 27.88. And I'm going to make sure, of course, that it's still in degrees. Yep. Man, I really thought by default it would have been degrees. Radians is not used as often, but there you go. It was in radians. Okay. 2 more, and that's it. 2 more. After we switched it from radians to degrees, we have not made a single mistake. Go us. All right, we have angle B is 52 degrees this time. They give us BC, the hypotenuse, and they want to know AC, the opposite. Opposite and hypotenuse is sine. We did that one, I believe, third. So problems 3 and 5 are from sine. The sine of B is opposite over hypotenuse. Ooh, x is on top, so we are going to multiply. So I'm going to multiply 30 times the sine of 52, closing that in 3, 2, 1, go. 30. Let's close out of this one. Remember, we don't even need to write the times. I can just hit 30 sine of my angle B. 23.640. The 0 makes it super easy to know we're not going to round that up. It's as low as it gets. 23.64. And boom goes the dynamite. 5 for 5. Last problem, and then we are done. Number 6 in our triangle A, B, C. Angle B is 64. They give us BC this time is 26. So that's hypotenuse. And they want us to solve for AB, that's adjacent. Adjacent and hypotenuse. Ah, yes, that is cosine, which I believe we started, and now we're ending this assignment with cosine. Kind of a cool symmetry. The cosine of 64 is adjacent over hypotenuse, so x over 26. X is on top, so we're not going to divide, we're going to multiply. So my final assignment, my final problem, I'm going to type in 26 times the cosine of 64, or just 26 cosine of 64. So it's this whole thing. Let's just get rid of this. Doesn't confuse us. 26, always side length first, then functions, cosine, angle B, 11.397. 7 is 5 or above, so we give it a shove from 39 up to 40. 11.40. You can also just put 11.4, but I'll leave the 40 there for you. Oh, please let us get it right. Yes, and look, it says 11.4 would have been accepted. All right. If you are still confused with jaw agape, I say go back and pause each one of these problems one at a time when you see the computation and just match up what my computation is with yours. Because it's going to be side length first, then whatever I write down. So if I write divided by sine, you write divided by sine, and then whatever your angle B is after that. Hopefully this makes sense. Oh my gosh, I opened this and previewed it. A record, very fitting for this assignment, 116 days and 23 hours ago. Holy cow. I started that on January 9th, and now I'm finishing it on May 5th. Wow. Don't know why I opened it that day. Maybe I taught it the previous year. Absolutely amazing. Okay, that's definitely my record, certainly on these videos. This has been a record all the way around. We learned what radians and degrees on Desmos were. I'm never going to forget that this wrench mark controls all sorts of cool options. Maybe I'll have to look in the other ones later, whatever projector mode is, what Namath is, UEB. I don't even know, but radians, degrees for sure. We got that. As always, I hope this video finds you safe, happy, healthy, and well. And if you got through this with 6 for 6, major props to yourself. Go get a reward. Get that dessert. Get that, time outside, maybe some video game time, whatever you do, some social media, because you have earned it. You have conquered our trigonometry lesson for the year, our Bowser of the unit of right triangles. Go you. So proud. Take care. Best wishes. Dylan out.